Thank you for standing by, and welcome to the Materialized Views How to Use Query Rewrite conference call. At this time, all participants are in a listen-only mode. There will be a presentation followed by a question-and-answer session, at which time, if you wish to ask a question, you will need to press star 1 on your telephone. I would now like to hand the conference over to your speaker today, Jens Vogt. Please go ahead.
Thank you. Hello to everyone, and thanks for joining us today. My name is Jens Vogt, and I would like to welcome you to today's Advisor webcast, Materialized View, How to Use Query Rewrite. Our speaker today is Shivata Da, Principal Software Engineer. We expect today's session to last approximately 60 minutes, including brief Q&A. All attendees can ask questions via the Q&A panel located on the right side of your screen, and phone attendees can also ask questions directly during our Q&A session. This is managed by an operator. We will start our Q&A with questions from the phone, and after this coming to questions from our Q&A panel, and all unanswered questions from the panel we will transfer to the community as always, and you will find the answer in the next few days in our community. This session is being recorded today, and after the Q&A, I will give you a brief demonstration how you can find the recording for this call and also the material. Our safe harbor statement: please remember this Advisor webcast is intended for information purposes only. Any feature or functionality described for Oracle's products remain at sole discretion of Oracle. Now, let's get started with our presentation. So, Shivata, if you're ready, I will turn over webcast to you, and you can begin.
Thank you. Hello, everybody. After completing this lesson, we should be able to describe basics of query rewrite, uses and benefits of query rewrite, enabling query rewrite, improving performance with query rewrite, troubleshooting query rewrite. In this webcast, I will cover the basics of query rewrite, purpose of using query rewrite, how query rewrite can be enabled and disabled, how we can troubleshoot query rewrite issues, and how efficiently we can tune an SQL statement to use query rewrite. Overview. Materialized views are basically required to support query rewrite. I assume you are already aware of materialized views. Let me start with a brief background of materialized views. Materialized view is a fancy term for a create table as select command, but materialized views are dynamic and flexible, unlike a create table as select command, which performs only a single copy of table data. Unlike a view, materialized view is not virtual. It is physical and can store data physically. Materialized views can be created with simple underlying select queries or queries involving joins, aggregates, etc. So now we have the results stored in the materialized views. In most of the data warehousing and OLTP environments, there are resource-intensive queries. For example, queries that involve expensive joins and aggregates, inline views, etc. When these queries are directly run on the master objects, they can be very bad performance-wise and can be resource-intensive as well. The end user wants fast access to data plus accurate data. Here comes in picture the use of materialized view and query rewrite. If a query with expensive joins or aggregates is run against the materialized view, which contains copy of the data, performance will be improved as the data can be obtained from the materialized view rather than querying the master objects. So, what query rewrite actually does? Database queries are written to access the tables in the database as normal queries. Then the optimizer will automatically decide whether it is cheaper to access the tables as originally specified in the query, or it would be better performance-wise if the query is rewritten and data is accessed from the materialized view. Refresh of the materialized view is required in order to get latest data in the user query. Otherwise, the result will not be in sync with the master objects. Capabilities and features of query rewrite. If the end user's query exactly matches the materialized view query, then all the information can be fetched directly from the materialized view. However, if the query contains only some columns that are present in the materialized view, then those column data is fetched from the materialized view and rest of the information from the master tables. Query rewrite is transparent to the end user. The end user need not to do any modifications in the query. End user can run the query in the same manner as against the master objects. Even if the materialized view is dropped, it will have no impact on the query, as in such cases, the result will be fetched from the master tables, and the end user will not be impacted anyways. Privileges. Grant query rewrite privilege must be granted to the user that creates the materialized view if all the objects used in the MView creation exist in the same schema. If master objects belong to some other schema, then global query rewrite should be granted to the user. Enabling query rewrite. Materialized views can be eligible for query rewrite if enable query rewrite clause has been specified either at the creation of the materialized view or materialized view is altered to have this clause. Now, in the coded box, we have created a materialized view with name test_MV. We have specified enable query rewrite clause in the creation of the materialized view. Now, since we have used enable query rewrite clause during creation of the materialized view, so this particular materialized view will be eligible for query rewrite. Alternatively, we can create the materialized view and later we can alter it to have enable query rewrite clause. If the clause is not specified and the materialized view is not altered to have this particular clause, it will never be eligible for query rewrite. The other parameters that are used to enable query rewrite are query rewrite enabled parameter, which can have the value of false, true, or false. Now, if the query rewrite enabled parameter is set to false, this option disables the query rewrite feature of the optimizer and directs the optimizer not to use query rewrite using materialized views, even when the estimated cost of the unwritten query is high. If query rewrite enabled parameter is set to true, Oracle calls the query with rewrite and without rewrite and chooses the method with the lower cost. This is the default one. If set to false, this directs the optimizer to rewrite queries using materialized views, even when the estimated cost of the unwritten query is lower. Next is optimizer underscore mode, and it can have values as all underscore rows, first underscore rows, or first underscore rows underscore n. Since cost-based optimization must be used, so this initialization parameter is very important. When set to all underscore rows, the optimizer uses a cost-based approach for all SQL statements in the session and optimizer with a goal of best throughput. That means minimum resource used to complete the entire statement. When set to first underscore rows, the optimizer uses a mix of costs and heuristics to find a best plan for fast delivery of first few rows. When set to first underscore rows underscore n, the optimizer uses a cost-based approach and optimizes with the goal of best response time to return the first n rows, where we can put any value in n, for example 1, 10, 100 or 1000. Verify query rewrite. If rewrite to a materialized view occurs, the execution plan of the query will contain mat_view rewrite access. I will further cover this in the forthcoming slides and demos. This brings us to our first demonstration, in which I will be creating a simple user, and we will try to see how query rewrite is done when there is a materialized view present. Now I'm connected to a 12C database. I will create a simple user, grant the necessary privileges to the user that are specific to materialized view, and then grant privileges that are specific to query rewrite. Here we go. I'm creating a user with name QRW1. I'm granting the basic privileges, that is connect and create session to this particular user. Now grant create any table to the user. This is a privilege that is specific to materialized view creation. And grant create any materialized view to this particular user. Grant select any table to the user QRW1. And grant alter any table to the user. Now grant query rewrite to QRW1 is a privilege that is specific to query rewrite. I have altered the user to have unlimited quota on the user's table space. Now I'm connected as the user, and I'm creating a test table for testing in this particular demo, and I have taken the information from all underscore objects and used a union with all underscore objects again. So the table is created. Let us set the auto trace on and try to figure out what the simple select query will tell us about the execution plan. So this is the execution plan of a simple select query. In the operations column, you can see table access full, and under the names we have the table name, that is test. Since as of now we don't have any materialized view, we don't have any query rewrite enabled, so the master object, that is test, has been used to fetch the results. Now let me create a materialized view log on this particular table, that is test. I will alter it in order to be eligible for fast refresh. And I will create a materialized view, that is test underscore MV with fast refresh option. The materialized view is created. I will again run the select query, that is select some object underscore ID owner from test group by owner, and let us see what the execution plan looks like. So now we can see under the operations, it is mat_view rewrite access full. That means query rewrite has been used for this particular select query, and the name, under the name column we have test_mv. That means test_mv materialized view has been used for rewrite. Now we will disable the query rewrite using parameter order session set query_rewrite_enable equal to false. And again, look into the execution plan. So this is now how the execution plan looks like. It is table access full. That means materialized view has not been used now. And under the names, we can see it is test table that has been used to fetch the data. So back to the main slides. So we have now the query rewrite types. When a query is rewritten, Oracle cost-based optimizer compares the cost of the rewritten query and the original query and chooses the cheaper execution plan. Query rewrite is enabled with cost-based optimization. Oracle database optimizes the input query with and without rewrite and selects the least costly alternative. The optimizer rewrites a query by rewriting one or more query blocks, one at a time. If a query rewrite has a choice between several materialized views to rewrite a query block, it will select the ones which can result in reading the least amount of data. After a materialized view has been selected for a rewrite, the optimizer then tests whether the rewritten query can be rewritten further with other materialized views. This process continues until no further rewrites are possible. When the rewritten query is optimized and the original query is optimized, the optimizer compares these two optimizations and selects the least costly alternative. Because optimization is based on cost, it is important to collect statistics on tables involved in the query and on the tables representing the materialized view. The various types of the query rewrites that are with us are exact match, join back, roll up and aggregate roll up, data subsets. We will go through these one by one. The very first one, that is text match. The simplest kind of query rewrite, that is, takes place when a materialized view definition exactly matches a query definition. That is, the tables in the from clause, joins in the where clause, and keys in the group by clause match exactly between the query and the materialized view. Now let us have a look into the text box wherein we have created the materialized view all_cust_sales_mv. Now in the underlying select statement, we can see the underlying select statement is same as the user select statement. The from clause and group by are exactly same. Since the user query exactly matches the underlying select query of materialized view, so this kind of rewrite is called as text match query rewrite, and data will be fetched from the materialized view, that is all_cust_sales_mv. Next is join back. Sometimes a query may contain reference to a column which is not stored in the materialized view, but it can be obtained by joining back the materialized view to the appropriate dimension table. Now in the example, we have create materialized view statement. And in this particular case, we have used group by customer ID and product ID, whereas in the user statement, we need group by customer last name and product ID. All underscore customer underscore sales underscore MV is the materialized view, and customer underscore last name is functionality dependent on customer ID because of the hierarchical relationship between them. This means this query can be rewritten in terms of the materialized view all underscore cust underscore sales underscore MV, which is joined back to the customer table in order to obtain customer last name column. Since materialized view is joined back to the master table, so this kind of rewrite is called as join back query rewrite. Roll up and aggregate roll up. When a query requests aggregates such as some quantity sold or some sales at a higher level in the hierarchy than the level at which the aggregates in the materialized view are stored, then the query can be rewritten by using the materialized view and rolling up its aggregate to the desired level. For example, our materialized view all underscore customer underscore sales underscore MV groups data at customer level, but we would like to report data at the state level. A customer dimension has been created which describes the relationship between customer and state. Therefore, the query will use our materialized view all underscore customer underscore sales underscore MV to reduce the reports where it will aggregate together all the data for customers and roll it up to the state level. Data subsets. The materialized view, which is shown in the example, that is sum underscore customer underscore sales underscore MV, contains data for Dublin, Galway, Hamburg, and Istanbul, and data is grouped by customer ID and product ID, whereas the user select statement wants data for Dublin and Galway. Now, since the data for Dublin and Galway is already present in the materialized view, that is sum underscore cust underscore sales underscore MV, so data will be taken from this particular materialized view, and there is no need to go to the master objects to fetch the result. Since the materialized view contains the data set of the user query, so this kind of rewrite is called as data subsets. Query rewrite accuracy. Query rewrite offers 3 levels of rewrite integrity that are controlled by session parameter query rewrite integrity, which can be set into the parameter file or which can be controlled using alter session or alter system parameters. The 3 values are enforced, trusted, and stale tolerated. Enforced. This is the default mode. The optimizer uses fresh data from the materialized view and only uses those relationships that are based on enabled, validated, primary, unique, or foreign key constraints. In trusted mode, the optimizer trusts that the relationship declared in dimensions and relay constraints are correct. In this mode, the optimizer also uses pre-built materialized views or materialized views based on views, and it uses relationships that are not enforced as well as those that are enforced. It also trusts declared but not validated, enable validated primary or unique key constraints and data relationships specified using dimensions. This mode offers greater query rewrite capabilities but also creates the risk of incorrect results if any of the trusted relationships you have declared are incorrect. In stale-tolerated mode, the optimizer uses materialized views that are valid but contain stale data as well as those that contain fresh data. This mode offers the maximum rewrite capabilities but creates the risk of generating inaccurate results. If rewrite integrity is set to the safest level that is enforced, the optimizer uses only enforced primary key constraints and referential integrity constraints to ensure that the result of the query are the same as the result when accessing the detailed tables directly. If the rewrite integrity is set to levels other than enforced, there are several situations wherein the output with rewrite can be different from that without rewrite. For example, a materialized view can be out of synchronization with the master copy of data. This generally happens because the materialized view refresh procedure is pending following bulk load or DML operations to one or more detailed tables of the materialized view. Or at some data warehousing sites, this situation is desirable because it's not uncommon for some materialized views to be refreshed at certain time intervals. The relationship implied by dimension objects are invalid. For example, values at a certain level in hierarchy do not roll up to exactly one parent value. The value stored in pre-built materialized view table might be incorrect. A wrong answer can occur because of bad relationship defined by enforced tables or view constraints. Query rewrite capabilities. The dbms_mview.explainmview procedure has been available since Oracle 9i, and it will tell you whether fast refresh is possible on a materialized view and what type of query rewrite may occur. When a materialized view is first defined, this procedure should be run as a part of verification process so that we can check that the materialized view will behave as expected or not. When the dbms_mview.explainmview procedure is run, it will populate a table called as mv_capabilities_table. And once this table is populated, we can perform select over this table and get more detailed information about the capabilities of the materialized view. Tune materialized view. dbms_mv.explainmv and dbms_mv.explainrewrite are the procedures that can be used to diagnose why a materialized view wasn't being used for a query rewrite. However, although these packages told us why rewrite hasn't happened, they let it down to us to work out how to alter the create materialized view statement to ensure that rewrite happened correctly. Now, starting with 10G, a new procedure came that is dbms_advisor.tune_mview that is built on this functionality and tells the DBs what changes we need to make to a materialized view to make it suitable for query rewrite. So dbms_tune_mview will provide certain recommendations. Once the recommendations given by tune_mv procedure are followed, materialized view will be eligible for query rewrite, and we can make use of query rewrite for user queries. This leads us to the second demonstration, wherein we will try to create the mview capability table and check out what results we can see from this. Now I'm connected to a 12C environment, and I will try to create the MV capabilities table. So in order to create the MV capabilities table, it is required to run a script that is utlx mv.sql that is present in the Oracle home under RDBMS admin. Now once this script is run, MV capabilities table will be created, and that can be further queried to check out what possible options could be there for rewrite. We need to create this table only once. Now this particular error message has been intentionally included because this means that the table can be created only once using this particular script, and if it is already present in the database, we need not to run this script again and again to create the table as it is already present. Now we will run execute dbms_mv.explain mv procedure, and we can input the materialized view name directly as we have input here test_mv, or else we can provide the underlying select query of the materialized view that has been used for the materialized view creation. So let us run this procedure. This procedure is complete, so we will now select over the mv_capabilities_table. Now we have run the select query over MV capabilities table where the capability name is like rewrite. We sometimes use it for refresh as well, wherein we give the capability name like refresh. And in this particular case, we are interested in determining the rewrite properties, so we have given the capability name like rewrite and ordered it by sequence. So this is the output that we get from this particular table. It says rewrite partial text match, yes. Rewrite general, yes. Rewrite PCT, no. And then it gives a short description as well. General rewrite is not possible, or PCT is not possible on any of the detailed tables. Now if we want more detailed information, we can run the dbms_advisor.tune_mv, which will give us much more recommendations, and sometimes it gives us the complete creation script, and if when we perform the recommendations, it can help us to make the materialized view eligible for query rewrite. Disabling query rewrite. You can use the initialization parameter query_rewrite_enabled to disable query rewrite for all materialized views, or to enable it again for all the materialized views that are individually enabled. However, the query_rewrite_enabled parameter cannot enable query rewrite for materialized views that have been disabled it with create or alter statement. The no rewrite hint disables query rewrite in an SQL statement, overriding the query_rewrite_enabled parameter, and the rewrite hint, when used with materialized view name, restricts the eligible materialized view to those names in the hint. So if we want a query rewrite to occur definitely using some materialized views, we can make use of rewrite hint, or if we want to force the query not to use rewrite, we can use no rewrite hint. This brings us to summary, and today we have discussed the basics of query rewrite, what are the types of query rewrite, how query rewrite can be enabled and disabled, and what are the various parameters that affect it. We have used how dbms_tune mview and explain mview can be helpful to determine which type of query rewrite can be used, and recommendations can be provided using dbms advisor.tune_mv.
So thanks to Shivata for this presentation, and we will now come to our Q&A session. First of all, for the users not using telephone, here's a screenshot where you can see how to ask the question. Type your question in the Q&A panel on the right side of your screen. Please leave the default, this is all panelists, and then press the send button. We will now start with questions from the phone. Operator, can you please remind our listeners how they may ask questions on the phone?
We will now begin our question and answer session. If you wish to ask a question, please press star then the number 1 on your telephone keypad and wait for your name to be announced. If you wish to withdraw your question, press the hash sign or the pound key. We'll pause for just a moment to compile the Q&A roster. And as a reminder, it is star, then the number 1 if you would like to ask a question. And there are no questions via the phone line.
Okay, thank you. So we will come to question from Q&A panel immediately. Our first question, why create any table grant is required for materialized query rewrite option?
Well, this particular privilege is specific not for materialized view query rewrite. It is for creation of the materialized view, because if the table that is used in the creation of the materialized view is not under the same schema, then the user that is creating the materialized view must have right on other schemas objects. That's why this particular privilege has been granted.
Okay, I hope this answers the question. And our next question, does cases and spaces matter the rewrite option?
Sorry, can you come again?
So this is the first question in our Q&A panel. Please check, does case and spaces matter the rewrite option?
Can you just brief it a bit more, because this seems somewhat incomplete. Cases and spaces matter in what case actually? But you want to specify the cases during the creation of the materialized view, or where?
Okay, so John Wilson, possibly you can clarify your question. So we see for text match, does cases and spaces matter for the text match?
No, it does not. It is only the statement. If the from clause, where clause, group by matches exactly the query that has been used in the creation of the materialized view, then it should go for rewrite.
So I hope this answers the question, John. If not, so please feel free to ask another question in our panel. We will come to the next one. Where can we find what type of query rewrite has been done?
Okay, so for this you can query the dbms_mv.explain_mv procedure can be run. That will populate mv_capabilities_table, and you can find out whether query rewrite is possible for this particular materialized view or not. And for a particular query, you can run dbms_mview.explain_rewrite, and it will provide information whether for a particular query the query rewrite will take place or not, and if it will not take place, what is the reason for not using query rewrite.
Okay, hope this answers the question. Next question, if the materialized view takes long time to build, how can we find out what is slowing down the process and how can we improve it?
Well, materialized view, that is a different area that is specific to performance of the materialized view. Maybe we can enable the tracing. We have certain tracings, for example, 146 trace file, wherein we can determine what are the recursive and non-recursive statements that are taking time. But I think that is not in the scope of this particular course.
Okay, sure. Hopefully the next one, does the order clause have any impact on the query rewrite?
Sorry, can you come again?
Does the order clause have any impact on the query rewrite?
Well, if the order clause exactly matches the order clause that has been used during the creation script of the materialized view, then it should go for text match. Optimizer first tries to match the SQL text of the query. If that fails, then it goes for more generic methods in which it compares joins, aggregates, selections, data columns, etc., and to make the query rewrite possible.
Okay, thank you. Next one. What database parameters need to support the rewrite?
So query underscore rewrite underscore enabled parameter and query underscore rewrite underscore integrity parameters effect, which we have already discussed in the slides.
Okay. Our next question. I noticed bind variables were not mentioned. Do they play any part in query rewrite?
Well, if the user query contains bind variables, the optimizer actually, under the covers, it breaks down the query into various subqueries as well. And wherever possible, it will try to rewrite if the cost of the query is less with rewrite. If it feels that the cost of the query is on higher side, then it will not go for rewrite.
Okay. Let's have a look to the phone. Operator, do we have questions on the phone now?
There are no questions via the phone line.
Okay, thank you. So we will continue. Next question. How can we make sure query rewrite has taken place?
We can check the execution plan, and if it shows mat_view rewrite access in the execution plan, then we can be sure that the query rewrite has been used for the particular materialized view. Otherwise, we can also query rewrite table, and it will give us the information if query rewrite has been used or not.
Okay, thank you. Next one. For what purpose the rewrite_or_error hint has used in the query?
Okay, if rewrite or error hint is used in the query will stop the execution of the SQL statement if rewrite cannot occur. In that case, some error will be thrown for the query. For example, it will throw 30393 error message. A query block in the statement did not rewrite. So it is just to force the query to throw an error if rewrite is not possible. If rewrite is possible, it will go for rewrite. Otherwise, it will throw an error.
Okay, thank you. Next one. Can query rewrite lead to wrong results?
Well, it can sometimes lead to inconsistent results depending on the value of query rewrite integrity parameter, which can have the value of still, tolerated, trusted, or enforced. The safest level is enforced, wherein the results are 100% accurate, but with still, tolerated, and trusted, the results may vary.
Thank you. Next question. Can we create materialized view without query rewrite?
Oh yeah, that can be always created for the general replication purpose, and without query rewrite also we can create the materialized view.
Okay, thanks, Shivata. Let's have a final look to the phone. Any questions at this time? So, operator, do we have questions at this time?
There are no questions via the phone line.
Okay, thank you very much. So this will bring us to the end of our Q&A, and we will now come to some instructions how you can find the material for today's session and the recording. First of all, I want to start with our generic advisor webcast note. This is the note number 740966.1. And starting from this note, you can find the material and recording for any Oracle Advisor webcast. So webcasts for all Oracle products are stored from this point. In today's session, so you have to search from the product list for database. So select database from this note, and this will bring you to the next note, which is a database-specific Advisor webcast note. And go to the archive, so always for the year, so we have 2016, so select archived 2016 here from the tab, and then go search your webcast. So let's say that's today's session, just for example. Then at the end of the line, you will see two links. One is a link for the recording, and here's a link for the material. And the third one, this is a link for the Q&A part. So if you have further questions after the webcast, you can use this one to ask your question in the relevant community. So this page will give you some more information, some links about our proactive work. And now, regarding communities, there are two ways how you can come to community, either by the community button from the My Oracle support page. This is one option, or option two, use the URL directly, communities.oracle.com. This will also bring you to the community. The community for today's session, this is Oracle database data warehousing. So in this community, you will find the discussion thread and also the material for today's session. I will show you the number at the end of this call. If you search for the documentation, then go on Contents, Documents, and this will bring you to the material. Here is a link to the thread. This is a thread for the discussion thread for today's session. If you have further questions, then please feel free to ask it here under this link. Now, this will bring us to the end for today's session. Thanks to Shivata, and thanks for all of you to joining us today. We hope you found this webcast valuable, and we look forward to having you joining us again. Please enjoy the remainder of your day.